Okay, this is Mark again, and we're going to talk about unit conversion today. I said in the introduction video that I wanted to talk about the BP oil spill of 2010 and use it both to talk about and practice unit conversion and think about the scale of the numbers in real world energy usage. So here we are. In that spill in 2010, 65,000 barrels of crude oil were leaking every day, and it lasted for over 11 weeks. Now, if you were paying close attention to the other video, you might notice that the number of barrels per day in this slide is different from what I said in the intro video. I ended up finding better figures as I was prepping this one, so these numbers in this video are more accurate. It was a major disaster, and a lot of effort went into stopping the spill, which involved drilling new wells and injecting concrete into the exploded section. It involved cleaning up the mess and investigating what went wrong and how to prevent such things from happening again. It's also important to point out that 11 people were killed in the explosion and 17 others injured. What we're going to do is figure out how much energy was lost in the spill in terms of the energy that could have been used in the spilled oil if it had been used as intended instead of having been spilled. So that's our problem. How much energy in BTUs, British thermal units, was lost in that spill, given that 1 barrel is 42 gallons, 65,000 barrels of crude oil per day, 11 weeks. So you're going to notice as I work on this little presentation that my handwriting is not very good, and I am in the process of learning how to use this tool. So I'm going to try to, as much as I can, type out things to keep it straight so you can read what I'm doing, and I promise I'll get better over time. So we've got our data, 65,000 barrels per day, and barrels is abbreviated BBL per day. That's a data point. We have 11 weeks. We have a conversion factor that 1 barrel, 1 BBL, is equal to 42 gallons. Another way to write that is as the fraction 1 barrel per every 42 gallons. Okay, and what's our question? Question is to figure out how much energy was lost in BTU. How much energy was lost in British thermal units? Okay, so looking at that information, I'm not quite sure how to proceed. I have information about barrels and days and weeks and gallons. I don't know anything about BTU, so there's some side questions I'm going to have to be able to answer. I may have to look some information up to be able to get this. So one, what's BTU? So I'm going to need to look that up and figure out how that relates to either the barrels of oil or the gallons of oil. And I'm going to have to do some unit conversion to be able to move between the barrels per day and the gallons and the whole 11 weeks and all of that stuff. So let's do that first. So I'm going to move over to the pen. This is the part where you might notice my terrible handwriting, and I promise I'm practicing. It'll get better. All right, here we go. So we've got 65,000 barrels per day, BBL per day. I'm going to write that as a fraction because you can see the rate, 65,000 barrels per day. Okay, and then, well, how many days was it leaking? Well, how many days? I'm not sure. It says weeks. There were 11 weeks. Well, I know that in 1 week there are 7 days. I'm going to write down the conversion factor between days and weeks as another fraction. 7 days in 1 week. The reason I write it like that is that when you're multiplying fractions, you do the top times the top and the bottom times the bottom. These units can cancel out just like regular numbers or variables can. So writing this like this, the days and the days will cancel out, And if I were to multiply 65,000 times 7, I would get the number of barrels in 1 week. Ha, that's cool. Well, that's not actually what I want, though. I want the number of barrels in 11 weeks. So now I want to multiply that by 11 weeks. And then notice that that's on the top. I'm going to put it over 1. It's just a regular fraction. And then cancel out the weeks. And what's left? I have the number of barrels. That would be the total number of barrels spilled in the accident. And I also have gallons. So let's do that one too. And we'll get times, I want to get rid of the barrels and turn it into gallons. So that's going to be 42 gallons in 1 barrel. Cancel out the barrels. And the units that's left is going to be the number of gallons that were spilled in the spill. Awesome. So now I'm going to switch over to a calculator, and I'm going to put those numbers in. So you should see I'm going to take 65,000 times 7 times 11 times 42. And there we go. This calculator doesn't quite write it out very nice, but maybe I can go over here and copy that number over into my answer sheet. So I've got that number. Let me put the commas in to make it a little bit easier to read. So comma, gallons of oil spilled. So that's 210,210,000 gallons. If I write that out down here, that's 210 times 10 to the 6th gallons. So 10 to the 6th is a million. 210 times 10 to the 6th is 210 million gallons. Perfect. That's how many gallons of oil were spilled. Okay, so now that I know how many gallons were spilled, I actually want to know how many BTUs, how much energy was lost. And I don't know. There's nothing in the data given in the problem to tell me the relationship between gallons and BTUs. So I'm going to have to look it up. I'm going to have to look up a conversion factor. And that's what Google's for. Sometimes we know those conversions, and sometimes we don't. And in this case, I find that I actually have a harder time finding a conversion to gallons. It's easier to find a conversion to barrels. So it turns out that 1 barrel of oil equals 5.8 million BTU. That's 5.8 times 10 to the 6th BTU. So I'm going to have to convert the gallons back to barrels to be able to get this into energy units. That's fine though, because I kind of wanted to know how many gallons it was, because I know what a gallon looks like. I know what a gallon of milk is. I know about a gallon of gasoline. So thinking 210 million gallons means something a little bit more to me than having calculated the number of barrels, because I haven't seen a barrel before. But I'm going to convert back. And the way that I do that is that I notice that the thing that turned it into gallons instead of barrels was that last step by multiplying by 42. So if I back it up 1 and undo that 42, I'll get the number of barrels. So let me go back over to the calculator and undo that 42. And I get, let me copy that again. This is going to be the number of barrels. So I got that, go back over to the whiteboard, and that's 5 barrels. Let me put the commas in so it's easier to see. Comma, comma. That's 5,005,000 barrels of oil. So I'm going to write that as 5 times 10 to the 6th barrels was the amount of oil that was spilled in barrels. So let me go and write that down. I've got 5 times 10 to the 6th barrels were spilled in the entire accident. Now notice I've been doing some rounding here. I rounded off that 210 million, and I also rounded off the 5 million barrels. That's because that number, the 5,000, is pretty small compared to the 5 million. It's 1/1000th of the size. And that 210,000 gallons is really small compared to the 210 million. I'm allowed to do that because of something called significant figures. The data in the problem only had 2 significant digits in it, the 65,000 and the 11 and the 42. So my result, it really only makes sense to report 2 digits in the result. So I'm rounding that a little bit. So there's 5 million barrels, and the conversion to BTU is 5.8 million BTU per barrel. So I'm going to put the BTU on the top, 5.8 times 10 to the 6th BTU in 1 barrel. And I know that I've done my conversion right because the barrels and the barrels cancel out, and the unit that's left is the one I wanted, which is the number of BTU. So if I multiply those two numbers together, I will get the number of BTU that were lost. So let's go back over to the calculator and make a new line, and I want 5 times 10 to the 6th times 5.8 times 10 to the 6th. Here, this did a nice job of converting it for me. 2.9 times 10 to the 13 BTU. That's a lot. So let me go back over here, switch the whiteboard, and copy that in. 2.9 times 10 to the 13 BTU of energy. There you go. Let me write that again. 2.9 times 10 to the 13 BTU. That's a lot, and we're going to have to do some thinking about how big that is to understand what that means. Okay, so let's try to think about how big that number is, 2.9 times 10 to the 13 BTU, and what that means. So 10 to the 6th is million. Let me put a little chart up here. 10 to the 6th, 10 to the 9th, 10 to the 12th. 10 to the 6th is million. 10 to the 9th is billion. And 10 to the 12th is trillion. So 2.9 times 10 to the 13 is 29 trillion. So let me write that in the text. That's the same as 29 trillion. 29 trillion BTU of energy. Trillion's a big number, but maybe it's a small unit. We need to figure out what that means. So this is tough. We've got really big numbers, and that's going to be the case the whole quarter. We're dealing with really big numbers, and we need to translate them into some form that is a little bit more relatable. So I'm going to do another unit conversion beyond the scope of the original problem to relate it to the amount of energy used in a typical household. So I need some new data. So new question, how many homes could have been powered with that energy? How many homes could have been powered with that 29 trillion BTU? Okay, so then I need to know something about a typical house. So one house in the United States uses about 12,000 kilowatt hours of energy per year. And here we go. We've got another weird unit because it's more convenient to report energy usage in kilowatt hours, electricity usage in kilowatt hours, than it is in BTU. So in the United States, at least, kilowatt hours is the standard unit for measuring electricity and other kinds of energy in the house. So what's a kilowatt hour? And what does it mean to have 12,000 of them? Well, 1 kilowatt hour is like leaving a nice computer on a desktop machine, not a laptop, for a whole hour. That's a kilowatt hour. It's like leaving a bright light bulb on for about 15 hours straight. That's about a kilowatt hour. And in the US, it costs between 10 and 15 cents. 10 to 15 cents for 1 kilowatt hour. In the Northwest, in Washington State, electricity is particularly cheap because we use a lot of hydroelectric power, and it's closer to 10 cents, and in some portions of the country it's a little bit higher. So if you do that math, that means that a typical household spends about $1,200 per year on electricity. So 1 kilowatt hour costs about 10 cents. A typical house uses 12,000 of those in a year. And here we go, the conversion factor, 1 kilowatt hour equals 3,412 BTU. So that tells you that a BTU is a pretty small energy unit compared to the kilowatt hour, which is what we measure electricity in. So I'm going to convert the number of BTU, the 29 trillion, into kilowatt hours. And then I'm going to think about how many homes that is. All right. So I'm going to take my 29 trillion. Let me scroll up a little bit so I can see this. Move this over here. So 29 trillion, 2.9 times 10 to the 13 BTU. And I want to convert that to kilowatt hours. So a kilowatt hour is 3,412 BTU. So 1 kilowatt hour divided by 3,412 BTU. And then I cancel out the units, and I've got it. Kilowatt hour is the unit that's left. So if I multiply the 29 trillion and then divide it by 3,412, that will give me the number of kilowatt hours. So I'm going to take that answer that I've already got and divide it by 3,412. Oops. So there we go. Take the answer from the previous, divide by 3,412, and that gives me 8.49 times 10 to the 9th. Okay. Copy that over. Make sure that you can see that. So down here, I've got 8.49 times 10 to the 9th kilowatt hours. So that's 8.5 billion. I'll write that out again. 8.5 times 10 to the 9 kilowatt hours. So that's better. It's a smaller number, and it's slightly more familiar because it's the unit that electricity bills are in, 8.5 billion kilowatt hours. And then I already said that one house uses about 12,000 of those per year. Okay, so that's the number of kilowatt hours that were lost. If I now divide that by the 12,000 kilowatt hours per year, I will be able to get the number of houses that could have been powered with this energy. So I'm going to take that, 8.5 times 10 to the 9 kilowatt hours times one house uses 12,000 kilowatt hours. Kilowatt hours. And then cancel out my units again. Kilowatt hours, kilowatt hours. And the unit that's left is going to be the number of houses that this would power. And that'll be my final answer for this little video. So 8.5 times 10 to the 9 divided by 12,000. So now I go back over to the calculator and take that answer 8.5 billion, and then divide it by 12,000, and I get 708,000. 708,000 homes. Let me write that nice and big so that you can see it. 708,000 homes. 708,000 homes could have been powered for a year with the energy that was spilled into the Gulf of Mexico in 2010 in that 11-week oil spill. That's the kind of scale that we're talking about. It's enormous. All right, so when you're doing your own unit conversions, I want you to remember to write out these fraction factors and cancel out the things that you don't want and get left with the things that you do want. And be sure to write down carefully what you're looking for and the information you have and your sub-steps. And be sure to talk to me and ask questions whenever you get stuck on these things. So that will be good for that question. 708,000 homes. Wow.